We are back today looking at another set of parent functions. We're going to look at the cubic and cube root functions. So starting with our cubic parent function, that is x to the third power. So I am going to make a little table for these points that I'm plotting and connecting. I'm going to start with 0. 0 to the third power is 0, so I know I have a point 0, 0. I can do 1. 1 to the third power is also 1, so I have 1, 1. Now with 2, 2 to the third power is 8. And that is going to max out the perfect cubes that I can fit there, but I can go negative, and negative 1 to the third power is negative 1. So negative 1, negative 1. And negative 2 to the third power is negative 8. So I can go negative 2, negative 8. And here is the shape of our cubic parent function. And looking at this graph and its key features, my domain is all real numbers along with my range. We don't have any values left off. We don't have a minimum or a maximum because it is going off in both directions infinitely. I have an x-intercept at that origin 0, 0, which means it's also my y-intercept. An asymptote is not a feature for a cubic function. And we do have symmetry, but it's not an axis of symmetry. What we have here is called 180-degree rotational symmetry. And that is around our point of inflection. So what that means is if I took this graph and rotated it 180 degrees over that point, it would line up with itself and the graph would essentially look the same. So that inflection point for the parent function is at 0, 0. So that is the point where we have, again, rotational symmetry, not an axis of symmetry. And then as I'm going from left to right, I am increasing the entire time, negative infinity to positive infinity, and it never switches to decreasing. Now let's talk about some different types of transformations that we can apply to these cubic parent functions. Just like with our quadratic and square root, we can dilate, stretching vertically, horizontally. We can shift left and right, we can shift up and down, and we can reflect over the x or y axis. So if I look at these three transformed functions here, I'm starting with this first one, that negative on the outside, that is going to be a reflection over the x-axis. And then that minus 5 on the inside tells me we are shifting to the right 5. Okay, on to the next one. That plus 4 on the inside tells me that we are shifting to the left 4. And then the plus 3 on the outside tells us that we are going up 3. And then on the last one, that 2 on the outside tells us that we have a vertical dilation by 2. The negative on the inside tells me that we are reflecting over the y-axis. Can't see that, sorry. And then that last minus 1 on the outside tells us that we are going down 1. Okay, so let's look at what changes about our characteristics when we graph these. So I am going to pull up Desmos again. And here we have in black the parent function, x to the third power, and I am going to put in that first transformed function in blue. And here we have it. We can see that reflection changes the shape, and then we shifted to the right 5. So our domain did not change. Our domain is still going to be all real numbers along with our range, which means we do not have a minimum or a maximum. Our x-intercept has changed, though. It is now over here at 5, 0. And then our y-intercept, I'm going to have to go up high to find. Way up here. There it is, 0, 125. I still don't have an asymptote. And then it's no longer that axis of symmetry. Again, it is still symmetry, but it is that rotational symmetry, and that is happening around the inflection point, which has now moved over here to 5, 0. So And then we are no longer walking uphill, we are walking downhill along this graph. So it's never increasing, but it is decreasing from negative infinity to positive infinity. Okay, let's look at our next one. I'm going to change this up in our Desmos. X plus 4 cubed plus 3 on the outside. And then looking at that blue graph, again, it did shift to the left and up, but our domain and range are still all real numbers, which means we do not have a minimum or a maximum. Our x-intercept did move. It is over here now at negative 5.440. And then our y-intercept, I'm going to have to chase it. Will it tell me? There it is right there, 0.67. Again, no asymptote. And then our rotational symmetry point is now this inflection point, which has moved here based on our transformations left and up. It is now at negative 4.3. So again, that rotational symmetry is at negative 4.3. And if I'm going from left to right, we are increasing everywhere, and we never switch to decreasing. Okay. Last one, I'm going to change this up to reflect our other transformations. There we go. Okay, so this one looks a little funky when they're overlapped, but our domain and range have not changed, which means we still don't have a maximum or a minimum. Our x-intercept did move. I'm going to zoom in to find that. That's right there, negative 0.790. And then our y-intercept is here at 0, negative 1. Still no asymptote. And then again, that rotational symmetry is now, that inflection point has moved to 0, negative 1. And as I go from left to right, I am no longer uphill, I am downhill, which means I'm never increasing, and I am decreasing from negative infinity to positive infinity. Okay. We are going to shift gears now and look at our cube root function, which is similar. Instead of inputting random x values, I'm going to make sure I'm putting in perfect cubes. So I can start with 0. The cube root of 0 is 0, so I know that's going to be there. I'm also going to go with 1. The cube root of 1 is 1. And then my next perfect cube is going to be 8. The cube root of 8 is 2. So my other point that's going to fit on here is 8, 2. And then I can also do negative 1. The cube root of negative 1 is negative 1. And then my next perfect cube is negative 8. The cube root of negative 8 is negative 2. So these are switched, those 2 points, the 8s and the 2s, from when we had our cubic function. So it's got a similar looking shape, but it's kind of like it's been flipped on its side. So looking at these characteristics, a lot of them are going to be similar. We still have a domain and range of all real numbers, which means we have no maximum or minimum. For the parent function, our x and y-intercept is at the origin. We don't have an asymptote, and this one also has, again, that 180-degree rotational symmetry at the inflection point. And the inflection point here is at 0, 0. And it is also an increasing graph from negative infinity to positive infinity, and it is never decreasing. So let's talk about transformations to finish this out. Looking at this first one, that plus 5 on the inside of my cube root tells me that we are going to be going to the left 5. And that minus 2 on the outside tells us that we are going down 2. On the next one, the plus 3 on the inside tells us that we are going to the left 3. And the plus 4 on the outside tells me that we are going up 4. And then finally, negative on the outside tells me that we are reflecting over the x-axis. The 2 tells us that we are vertically dilating by 2. And then the minus 5 on the inside tells us that we are going to the right 5. So let's look at those 3 graphs in Desmos and see what changes. I am going to change this up. So here again we have our parent function in black for cube roots, and I'm going to put in that first transformed function in blue here. So we can see that general shape changed, but it did move over. So our domain and range are still the same, which means we don't have a maximum or a minimum. Our x-intercept has moved. It is over here at 3, 0 now. And our y-intercept is now here at this point. Let me zoom in to find it, because right now it's giving me the intersection point. There we go. There is our y-intercept, 0, negative 0.29. Okay. We do not have an asymptote. And then again, for that rotational symmetry, that is going to be about the point of inflection, which is here. Again, I don't want where they are intersecting. I want that inflection point, which is based on my transformations left and down, so at -5, -2. And then this graph is increasing as I go from left to right, and it never switches to decreasing. Okay, looking at our next one, I'm going to throw in there x plus 3 and x plus 4. So we can see where this one has shifted now. Our domain and range are the same, which means we don't have a minimum or a maximum. My x-intercept, I'm going to have to scroll over here to find. See if it tells me there, -67, 0. And my y-intercept, then for my y-intercept, I'm going to scroll back over here, and that is at 0, 5.44. Still no asymptote. Our rotational symmetry point did move here. That point of inflection at our transformed points is there, right there, -3, 4. And this is still an increasing graph as I go from left to right. It will never switch to decreasing. Okay, and then for our final transformed graph, I'm going to adjust the equation in Desmos. And this one has now flipped around, so a couple changes happening here, except for the domain and range. If you haven't caught on yet, those are not changing based on any of our transformations. Our x-intercept, however, is now at 5, 0. And our y-intercept is here at 0, 3.42. Still no asymptote. And then our rotational symmetry point is at the inflection point, which is here at 5, 0 as well. And this graph is now decreasing everywhere from -infinity to +infinity, and it will never switch to increasing. Okay, and that wraps up our notes on cubic and cube root functions.